Hi, my name is Stephen Gray and I'm from Michigan State University, and I'm joined here with...
Allison Singer, also from Michigan State University.
And this is the first of a series of videos on introducing the idea of systems thinking and modeling using Mental Modeler. Now, Allison, I assume all problems are the exact same. Is that right?
That is not right, Stephen. So we can categorize problems into two main categories, tame problems and wicked problems.
What's the difference between the two?
Tame problems are problems that have a solution, so problems you can solve. Wicked problems are problems that you can't really solve, and you need to think about a lot of different ways to try and manage the problems.
So let me ask you this. Would a tame problem be something like how to get across a river?
It would, and how might you solve that problem, Stephen?
By building a bridge?
That's a great idea.
Now, what about wicked problems? It seems like an example of a wicked problem might be something like climate change, or how do we stop overfishing?
Okay, so you're absolutely right, Stephen, that climate change or managing overfishing are examples of wicked problems. How might you manage overfishing?
Well, in those situations, there's not a clear solution. So what we might do is use a variety of means, like catch shares or determining fishing quotas or managing habitat, and those might help us better manage the fishery.
Those are great ideas.
So if you had to think of systems as a metaphor, is there some kind of metaphor that makes sense to you?
Sure, there's a metaphor of the iceberg.
Oh.
And the reason that's a great metaphor is because what we can see and observe is just the tip of the iceberg, but there's a lot going on underneath the surface that actually creates the iceberg itself.
So would you think about a systems thinker not only sees the events or what they can see, but they also think below the nature of the problem to understand the entirety of the system that actually causes that problem?
Exactly.
It's fascinating. Now, we're talking a lot about systems thinking, but we haven't really defined a system. What is a system, Allison?
Well, so Donella Meadows, who's very famous in the systems thinking world, defines it as a set of parts that are organized and interconnected in ways that produce a characteristic set of behaviors or outcomes.
Well, that's all fine in the abstract, but can you give me some clear examples of what systems might be?
Sure. The human body is a system that we're all very familiar with.
I see that, yeah. Is there anything else?
Yeah, you've got the biosphere as a system. Economies are systems.
I see. And are all systems the same?
No, so the systems I just talked about are all self-organizing systems, but there's also engineered and man-made systems like car engines or airplanes.
Oh, that's very helpful. Now, so you were trying to promote this idea of systems thinking. What are the goals of a systems thinker or fostering systems thinking?
So again, if you go back to the iceberg, I think we want people to think about more than what they can see and think about what actually creates the events and data that we can observe so that we can try and manage these wicked problems.
So are systems thinkers going to look for patterns?
They are.
Are they going to look for structures that kind of drive the underlying event?
Yes.
And I assume that they're going to be concerned about short-term strategies.
No, they're also going to be thinking about long-term strategies.
Fascinating. So are there characteristics of a systems thinker?
There sure are.
What are they? I assume that they just see a part of the picture?
Nope, systems thinkers try and look at the whole picture.
I see, and their perspectives are very fixed.
Nope, systems thinkers are willing to change their perspectives to try and identify new leverage points.
But they're probably not looking for anything in particular, are they?
No, they're actually looking for interdependencies within the system.
But their scope is going to be very narrow on these problems, right?
No, they're going to have a wide scope.
And are they going to look for just confirming their anticipated changes that they're looking for?
No, they're also interested in unanticipated consequences that might occur.
But their perspective on the problem is going to be completely fixed, I'm assuming.
No, they're going to change their perspective and they're going to listen to other people's perspectives also.
I see. And what about their time frame?
They're interested in both short-term consequences but also long-term consequences of change.
I see. So you might say that systems thinker is just a certain type of perspective that people have that's wide, that is allowed to change, that puts yourself in other people's shoes so they can find and think about a problem more deeply.
I think you're really starting to understand it, Stephen.
Now, how would one foster systems thinking?
Well, we often foster systems thinking through systems modeling.
And what is a model?
A model is just a representation of a thing or a system.
And then I assume there's only one type of model?
There's two broad types of models that we'll be talking about. We'll be talking about mental modeling, which is what occurs in our heads, and we'll also be talking about scientific modeling, which is a more formalized type of modeling.
Well, I look forward to hearing more about this in our next video about the different types of models and how they can help support systems thinking.
Me too.
Thanks, Allison.
Thanks, Stephen.